Hi. One of the many things I ask you to do when we look at chemicals is to think about the conservation of mass. And some people get it and some people don't. So what I've tried to do is simplify it even more for us, and hopefully this will be good, and hopefully we can see what's going on. We know that with conservation of mass, we just rearrange atoms. So in other words, the number and type of atom doesn't change from when it's a reactant to when it's rearranged and becomes a product. Right? So make sure you do this. You don't sort of change. You might say I've got 27 atoms as reactants, 27 atoms as products, but those atoms also have to be identical. And this is the thing that many people miss out on. So we don't actually change the atoms or do anything like that as we do this conservation. Right, so let's look at a nice simple one. Propane is a gas that is often used in barbecues. It is made of, or basically it is composed of, carbon and hydrogen atoms. And there are 3 carbon atoms and 8 hydrogen atoms in each molecule of propane. Now when propane is burnt, we know the typical products of propane, or of any fuel basically that's burnt, is going to be carbon dioxide and water. That is, of course, provided there is enough oxygen, and that's another story. So what we've got to do is to look at the number of atoms. Now when we look at it this way, we see that there are 3 carbon atoms here, and 3 in the front means 3 of everything here, like a simple math expression. So it means 3 carbons and 3 times 2 or 6 oxygens. So I've got 3 carbons here and I've got 3 carbons here. The amazing thing is they are the same 3 carbons. Well, this is something I don't want you to forget. So these carbons are the same. We've got 8 hydrogens and we've got 4 times 2, which makes 8 hydrogens. Alright, then we've got 5 times O2, so 5 times 2 is 10 oxygens, and we've got 3 times 2 is 6, and 4 times 1 is 4, so we've got 10 here. So we have obeyed our law of conservation. And this is shown rather clearly as we go through. I've highlighted the atoms into different colours so you can trace them on the way through. So when you are doing this and doing conservation of atoms, you must not only consider the number of atoms on both sides being the same, but the number of each type of atom on both sides being the same. And as we can see, when I look at the oxygens, we can actually go through and see the same thing. Hopefully that makes a bit more sense.